Did you ever wonder if there is an open source automation tool where your team can integrate code into a shared repository and at the same time it can be checked for bugs and errors? This is John from Java Code Geeks, and today I'm going to show you how to write clean and efficient code in Java by using continuous integration with Jenkins. This video has been sponsored by DiffBlue. DiffBlue offers a free AI-powered unit test generation tool for Java developers. This AI, or in other words DiffBlue's cover, has the ability to automatically write suites of unit tests for you in Java that would otherwise take days or weeks to write manually, and delivers human-readable code to increase your code coverage while ensuring you don't break anything along the way. Of course, DiffBlue's first AI-powered automated Java unit testing solution is now free, and it is available as a plugin of IntelliJ, the most popular IDE for enterprise Java to use with all Java code. Last but not least, each of you has the chance to get 3 free months of DiffBlue's Professional Edition, which is offering test writing for packages, identification, and support by signing up using the link in the description below. Jenkins is one of the most popular continuous integration tools used today by software teams and is playing a significant role in DevOps. Furthermore, it is an open source continuous integration platform that has thousands of native integrations with useful tools. Now, complementary to this video tutorial, you can find related articles and resources in the description below. Of course, you can visit Java Code Geeks to stay up to date with everything Java related. Now, before we continue, if you guys like these guides and videos, take a minute to subscribe, like, and hit that notification bell just so you know when the next video is up. So with no further ado, let's get started. Jenkins is an open source automation tool written in Java with plugins for continuous integration purposes. Jenkins is used to build and test software projects, so it is easier for the developers to integrate changes to the project, and it is easier for the users to obtain fresh build. Also, this allows you to continually deliver software by integrating with large numbers of testing and deployment technologies. Jenkins is a server-based application that requires a Tomcat server to be able to run through various platforms such as Windows, Linux, etc. To be able to use the Jenkins, we need to create pipelines. More specifically, a Jenkins pipeline gives you an overview of where the tests are located. Furthermore, in build pipeline, the build is divided into some sections such as unit test, acceptance test, packaging, reporting, and deployment phases. The pipeline phases can be executed in parallel or series, and when a phase is successfully completed, then we can automatically move to the next. Now, Jenkins continuous integration pipeline consists of some tools like the continuous integration server like Jenkins, the source control tool like Git, the build tool like Maven, and last but not least, the automation testing framework like Selenium. Jenkins uses master-slave architecture to be able to manage distributed builds. The master and the slave can communicate with each other with the help of TCP protocol. Your main Jenkins server is the master. The master jobs are scheduling build jobs, dispatching builds to the slaves for actual execution, monitor slaves, and last but not least, recording and presenting the build results. Now, the slaves are a Java executable that runs to a remote machine. The characteristics of a slave are: it hears the requests from the master, can run to a variety of operating systems, and last but not least, executing build jobs dispatched from the master. As for continuous integration, is the practice of automating the integration of code changes from multiple members of the team into a single software project. It is a primary DevOps best practice where allows the developers to frequently merge the code changes into a central repository where builds and tests are performed. One of the key benefits of integrating regularly is that you can detect the errors quickly and locate them more easily because each change is typically small. Through the years, continuous integration has become the best practice for software development, and it's guided by a set of key principles, which are revision control, build automation, and automated testing. To understand how Jenkins achieved continuous integration, let's see a small example. In a software product development project at Nokia, they used a process that we called as night builds. Night builds, we can say that is the predecessor of continuous integration. Night builds process means that a specific automated system pulls the code and adds it to a shared repository and builds the code. The idea is quite similar with continuous integration, but the code that was built is quite large, so it is difficult to find and fix the errors. So the company adopted the continuous integration. Now every commit was added to the shared repository was built. If the build result shows that there is an error to the commit, the only thing that developers need to do is to check this specific commit and fix the errors. The idea has a result to reduce the time required to release new software updates. The most significant challenges on implementing an effective continuous integration are it is difficult to maintain continuous integration because the teams must build proper test suites and spend time on writing test cases. At first, this could slow them down, and secondly, they will not complete their own task on time. Secondly, for larger developer teams, they may see continuous integration messages for errors daily and they will start ignoring them altogether because they have other tasks and concerns. And last but not least, some businesses prefer traditional methodologies and they would have hard time to implement the continuous integration, or they have to retrain the staff members, which would mean overhauling existing operations. In case that we don't use continuous integration and we develop a source code for an application and then deploy it for testing, we will conclude that we will have many flaws. These flaws are the developers must wait until the complete software is developed for the test results. Secondly, there is a high possibility that the test results will show us multiple bugs. Thirdly, it will slow the software delivery process. Furthermore, continuous integration pertaining to things like coding or architectural issues or build failures were missing. As a result, the quality of the software will go down, and last but not least, the whole process will be manual, which increases the risk of frequent failures. To be able to understand how Jenkins overcomes the above shortcomings, let's see how Jenkins works. At first, the developer commits the code to the source code repository. Meanwhile, the Jenkins server checks this repository at regular intervals for changes. Soon after the commit, the Jenkins server detects those changes and pulls those changes to be able to start building a new build. If the build fails, then it notifies the developers, or else deploy this build to the test server. Last but not least, after testing, the Jenkins server notifies the developers about the build and the testing results. In this example, we will show you the continuous integration with Jenkins. The requirements for this example is to create a new GitHub account and to download the Jenkins tool from the official site. So the first thing that we need to do for this example is to create a new project and a new class with a name calculation. In this example, we create a new method with a name findMaximum, which has a parameter which is an integer values array, and then we try to find the maximum number from this array. Inside the method, we initialize a new max integer with the first value of the array. We create a for loop in order to access all the array. We find the maximum number of the array, and last but not least, we return it. Now, we create a new main method to be able to call the findMaximum with some values, and we print the result. The next step is to commit and push our code to GitHub. So we need to go to the toolbar, click the VCS button, and we click Enable Version Control Integration. Then we press Ctrl and K button to open the Git. We check all the files, we write some description, and last but not least, we push commit. After that, we go again to the VCS button on toolbar, then Git, and we press push. As we can see, it asks for a GitHub repository. So in this step, we need to open the GitHub and to create a new repository. To do that, we need to go to our profile page, repositories, and then press new. I will name it as calculation and it will be public. Finally, we copy our URL. Last but not least, we open again the IntelliJ, we paste the origin URL of our repository, and we click push. Finally, we open Jenkins from our local host. In this step, we want to build and run our project. To be able to do that, we need to select new item from the sidebar. We enter the name of our project, then we click Freestyle Project, and last but not least, we click OK. After that, we can see so many options to fill, but the only thing that we need to do is to add our repository link. To be able to do that, we need to go to Source Code Management, and then click Git. Then we add our repository link here. Then we select GitHub hook trigger for Git's CM polling, which means that every time we commit code to the GitHub, the build is triggered. Last but not least, we select build to add a build step and click the execute Windows batch commands to add the commands to execute our code. Finally, we click the save button, and at the next page, we click the build to run our project. When the build is successfully complete, we can click on console output, and as we can see, the max number of the array is 4. The benefits of using Jenkins tool are: at first, the development cycle is reduced because since every commit is getting built and tested, it allows to release new features to the user faster with no errors. Secondly, the time is shorter to integrate code. Before Jenkins continuous integration, the integration was done manually by the developers, as the result to take a few days. Now, when we integrate code after every commit, we ensure that the functionality at least is not broken. Thirdly, the feedback is faster for the developers because when a test breaks during the commit, they get feedback and improve the code whenever the problem is. And last but not least, the workflow is automated, so the developers doesn't need to worry about manual tests after every commit because Jenkins continuous integration pipeline checks the latest code and builds the code along with the tests. Jenkins is a very powerful tool, but it has its flaws. At first, Jenkins' interface is outdated and not user-friendly compared to other user interfaces. Secondly, Jenkins is loved by many developers, but it is difficult to maintain because it runs on a server and requires some skills of a server administrator. Furthermore, many people don't implement Jenkins because it is difficult to install and configure it. And last but not least, continuous integration regularly breaks because of a small setting changes, so it requires some developers' attention. So, I hope you enjoyed this video. If you did, be sure to smash the like button and subscribe to our channel. We have some really cool stuff coming up. Bye!